All right. We had to set up extra chairs. I was hesitant to do so because I figure after 15, 20 minutes, we won't need so many chairs and tables. Everybody sees the equation on the board. We're going to work on that first. and then we'll go from there. Anybody recognize what that equation is? Nobody knows what that equation is?
The last two letters looks to me like the velocity of a pitchfork.
Yeah, something like that. Something like that. Well, I want to check that. That's the reason I put that up. Because if no one here knows what that equation is, then you're not going to realize how stupid I am in this presentation. so I'm safe. You know, it's like in Kentucky, I speak a lot of Hebrew, but if Rabbi Woolman's around, I speak English. No, I'm up there. I'm fluent. A regular Sabra almost. Do we have an automatic thing for this, or I have to do it on the computer? I wonder if it would work on my computer, though. I doubt it.
It's an attachment you have to get. I think Roger keeps it in his office.
Okay, well, in that case, we'll have to step over and hit it. All right. So I'm delighted that so many folks felt led to turn out. I prayerfully hope that you'll be able to come back next time. When I first got into this subject, Mr. Helene, and I wrote up the little booklet that you got, Mr. Helene wanted to put this first chapter as an appendix so that people wouldn't be afraid. But I overrode that advice. And should we pass that around? Yeah, get everybody's name. Maybe a name in your bank number. And last four. Just your name is fine. Some of you I know, and some. Now, it's going to be really important that you don't ask difficult questions because I'm old and feeble and I know I won't be able to answer it. We'll wait for Joyce. We don't want to start without Joyce. That's right. I have to ask you again because more people are coming in. So if anybody says Schrodinger, I'm dead. Okay. The purpose of this course, what I would hope to achieve in you in this course, however long it takes us to go through, it doesn't matter to me how long it takes. Well, mowing season starts in April up north. So it's going to have a boundary there for sure. But we can't hear him? Oh, okay. So you want me to speak more loudly? All right. I'll try to speak more loudly. I'll get a little reverb in the hall here. There's no, I really don't know how long this thing is going to go on. To me, it's a fascinating subject, and my objective as teaching the course and writing the book is to counter the impact of Gnosticism in Christians' thought today. And it's been that way for 1900 years, so it's not a new thing. Virtually every hymn that you sing talks about going to heaven. And there is a fallacy in the perspective. And because you all know the Lord's Prayer, thy kingdom come, thy will be done in heaven like it is in earth. Not that way. So God's will is already being accomplished in the heavens, and it needs somehow and some way to be brought down to earth. To earth. So the concept of redemption, and we'll try to develop this as we go along, but the concept of redemption is I got saved and I'm going to die one of these days and I'm going to go to heaven and I don't know what's going to happen, but that's it. That I want to counter that concept. I have a slide in here somewhere that says the objective here is for you to envision that you're going to spend eternity on planet Earth, whether it's in this present age or in the new creation that is to come. God's kingdom is descending upon this world, and so Gnosticism, and this is way late in the course, but Gnosticism made a religious thing of anything physical is evil, and so they were trying to escape it, and so they developed special knowledge to allow them to reach to a higher plane of existence, which was heaven, and that has so influenced Christianity that that's virtually common in all Christian thought. And so the purpose of this course is to counter that. In studying and teaching through the scriptures over the years, many years now, I hate to think how many years. Gosh, I mean, we're talking in multiple decades now. I feel pretty young, actually. I don't look it, but I feel pretty young. So you run through Genesis, and you see Abraham being promised a land. And years ago, whenever I was studying, teaching through that, I always saw it as, up in Kentucky, you got two kinds of lands. You got hilly land, and then you got bottom land. Bottom land's land along a river or creek. And that's usually very fertile, and the hillsides are not so fertile. All the topsoil, the hillsides have eroded down, and they're down in the bottom land. And so if a father gave a favorite son, maybe his firstborn, for example, biblically speaking, the best of the land, he would give his son the bottom land. And his least favorite son, maybe the hillsides. And I always thought Abraham traveling through the land, Abraham was a friend of God. God favored him. He loved him. And so I always thought in the sense that God just decided to give the best he had to Abraham. Actually, after traveling to Israel several times, the land itself didn't look not that great. But anyway, that was the concept. Eventually, though, I realized that God chose the land before he chose Abraham. And so when God separated Abraham and says, go where, lech lecha, go where I'll show you, God knew Abraham didn't know where he's going, but God did. And God purposely directed him. We don't know exactly how he did that, but he directed him to the area that we call the land of Israel today. And as soon as Abraham met God in the land, God must have revealed himself in an awesome sense. It was a place called Elon Moreh, We know it as Shechem or Kedumim. Most of you have been to Kedumim, worked there, so you know exactly. So now, Kedumim is not that, it's not Iowa cornfields. It's pretty rugged land, isn't it? It's hard to work and a lot of rocks and whatever. So the land itself wasn't such a wonderful thing, but as soon as Abraham met God there, something powerful in the sense of revelation must have taken place, because Abraham built an altar there and worshiped. And so I believe that God revealed himself in such a way, just knocked Abraham's socks off. I assume he wore socks. Everybody wears socks. So powerful revelation. And you'll see in the scriptures, from time to time, God will make himself known to Abraham, and Abraham will build an altar. And he built altars all through the ridge country of Israel, from Shechem to Beersheba. Actually, I think Isaac built one in Beersheba, but he went at least to Hebron. And so I began to get the idea that this place, this high country, this ridge country, from God's standpoint, must have some special significance. And so we want to work on that thesis for the next few weeks, because I believe that it is that territory, that land is expressly chosen by God for an express purpose, and he has chosen a family of people to be stewards of that land. And whenever the people that are stewards of that land inhabit that land, God's redemption purpose is accelerated and speeded up and is happening rapidly. And there's where we are today. We have been blessed. Now another thing that there's several just facts that just startle me almost to think about it. Every one of you here, I presume, believes that you have made Jesus Lord in the Holy Spirit and are continuing to do so on a day-by-day basis. You are the first believers to do so since Peter, John, and Paul did the same thing that you're doing when Israel was in the land. When the guardians of that land actually possessed that land under God's authority. You're the next generation of believers since then. Now, when you get home tonight, sit down on the back porch and take your shoes off, sip your tea or whatever you do, and just think about that a moment. Because you have a kinship with Paul, you have a kinship with Peter and John and those guys, because you're that next generation that have become believers when these things are, this incredibly important event has occurred, the union of God's people and his land. Most of you have been there, you've walked in. Joe and I went there almost 40 years ago now. It seems hard to believe that I could be that old, huh? Almost 40. I wasn't that young when I first went. But anyway, I thought I was a hot dog, kind of a Green Beret type a believer. I mean, I was, most people kind of live a backslidden life, but not me. I was a hot dog. And I walked in the land, and I just melted. The awesomeness of the presence of the Lord was so incredible that I realized how incredibly juvenile I really was. It was like I was born again. And I went to bless Israel, and I returned blessed. And I returned saying, please God, please Jesus, make me fruitful, at least as one of these so-called unbelieving Israelis. That was my prayer, returning. I wrote a little book, God's Final Call, outlined it on the plane coming home. And that book was going to change everything. It didn't change anything. At least I didn't see it immediately. Anyway, we have fun with that. All right, so with that in mind, now, again, I don't know how long this is going to take. I hope that I will share this with you. I have worked incredibly hard attempting to prepare to teach this class. Most of my summer reading since early spring last year has been preparing. And I feel incredibly inadequate to do that. But we're going to take a shot at it. So let's look at some slides and see what we might find. See if I can make this work. You going to work? You're not going to work. Well, it usually works here. All right. What is that? The night sky. Oh, whoops. Now it works. Now, let me play with it a little bit. I'm going to go back a little bit. I got something. This is going to probably take a long time. Yeah, kill some of those lights because you can't see that, can you? That's a beautiful picture. Several. Yeah, you don't need to see me anyway. Yeah, that's good. Eh? Several years ago, we made some friends out in West Texas, and so Mr. Klein and I would go out there and do TV programs that we did in those days, and then following that, there's a group. We started a class, a Bible class, over there, and then some people coming in from New Mexico to join that class, and eventually they asked us if we wouldn't just drive over to New Mexico while we were out there, which we continued to do. And so one night, Joe and I were driving back from, what was the town in New Mexico? I can't remember, southern part of New Mexico. Anyway, we were driving across the high desert at night. And out in the desert, there was no lights, no civilizations visible in any direction you are. We happened to have rented a car that had one of those sky windows on the top, whatever you call them. And so we just stopped and pulled that thing back and looked up. We were just sitting beside the road, just looking like if I was downtown New York, just looking up. And the enormity of the stars that were visible from that vantage point, because we were talking about relatively high desert, I don't know, 3,000 or 4,000 feet, and no smog, no clouds, no anything, and no lights. And when God said to Abraham, look up and see, if you can count them, that's how many of your descendants, he must have seen something like that. It was incredible. So we look at, so in the beginning, God created, you all know the story, the heavens and the earth. You all know that scripture. I've been working on this. Bereshit bara Elohim et hashemayim v'et haaretz. Fluent, see? Tov me'od. All right, now we're going to talk a little math, and now I just spoke that verse in Hebrew. Now that didn't scare anybody, did it? Did that scare you? Nobody's afraid of a verse in Hebrew, huh? Okay. Remember that math is just a foreign language. So if you think there's no reason to be afraid of math. And so this is just a simple way of saying the creation. By the way, this is in your book. somewhere around page 2 or 3, I guess. When you in the language of mathematics, when you use the symbol sigma, capital sigma, like so, it means the sum of. The sum of. So now you all know that we can divide up space by the distance from here to the front door, the distance from here to the ceiling, and the distance from here to the side door, X, Y, and Z. Now, if you think about the picture of that great, incredible universe a few minutes ago, you could literally define any point in that space by those 3 X, Y, and Z coordinates. These are considered coordinates. And T just represents time. So if you go back to the creation event, if you're what do they call them? Tim will tell us. Young Earth. Then how many? What was time 0 about? 6,000 years ago. If you are more scientific oriented, I guess, in that sense, you go back. You get different estimates, but the latest one I read was 13.8 billion years. But to tell you the truth, we're talking about Earth time, and don't get too excited about it because it's irrelevant. Okay. Now, remember in the beginning, God created the heavens and the earth. You don't work good, do you? Come on. Oh, there. How about that one? I added that one, Mr. Lynn. Now it's giving me the previous. These are tricky things, aren't they? Can you roll the little wheel? Everybody understand what this is? It's a picture of the Milky Way. And I picked it because it identifies where we are. You are here. I like that. So that's one of thousands or millions of galaxies in existence, and you can just go on and on and on. If you want to, at break, I'll calculate. If you figure the Big Bang started at a point, and light travels at a finite speed, you can calculate how far out light has gotten from the Big Bang. I sat down and did that one day. You can figure out how big the universe is in that regard, at least as far as light has reached at this point in time. All right, so did we go backwards or forward? Okay, now, if you can describe the earth in those terms, then we want to talk about, how about this heaven thing? So in the beginning, God created not only the earth, but the heavens. And so let's just assume that we could choose some dimensions, which we don't know what they are. Anybody knows what the dimensions of heaven are like? We don't know. So I arbitrarily call them P, Q, R, and some dots because I don't know how many there are either. But I just use this in its language as a sum of all of these points would represent the spiritual universe. So I'm saying that what the Bible is telling us is that God has created two universes, two parallel universes, the heavens and the earth. The heavens and the earth. And so that's what we're working at. Okay, let's go on, if I can get it done. Now, you all know the scripture that tells us that man was created in the image of God. I figured God was about 5'8", bald, and a little chubby. Is that what you think it means? You don't think it means that? So what does it mean? Man was created in the image of God. What would he have meant by that? Well, I think we must have been created with some attributes that are common with what godly attributes. And let me suggest, and this is my suggestion, you have to think about it. Just because I say it, you don't have to receive it. But I believe, since we know that God operates, Isaiah wrote, heaven under the anointing of the Holy Spirit, heaven is my throne, earth is my footstool. So that's declaring that God functions both in both of these universes or both of these realms. God functions. In the heavens, we don't have any doubt about that, do you? How about on earth? Does God function on earth? All right, I want to suggest that man was created in the image of God with the capacity to function in both heaven and earth. Like God. Pardon? Parallel. Well, parallel or somehow, we don't know. The only thing that I think we're really confident in is there's two distinct realms that we're talking about. How they interact is a difficult question to answer. All right, so let's move on. We believe that this statement implies that man freely interacted both in heaven and earth. And we're talking about before the fall. We hear of Adam walking in the garden in the cool of the day, and it seems like there must have been a complete interaction between Adam and God without restraint. Any of you ever feel like when you're praying, sitting on your back porch and you're praying, you keep going to sleep and you feel like your prayers are not being that effective? And you kind of wish you could take a few steps into heaven and maybe communicate a little more clearly? And often, I know for sure, I'm hoping that God will come in. Maybe I don't want him to, but that he will speak a little more clearly also. Maybe he'd say, you know what God said to Elijah? He found him at Mount Sinai. What are you doing here? So I found myself in Kentucky, and the Lord says, what are you doing here? He didn't really say that. I felt that, but anyway, we believe that in the original creation there was no limitation to the communion capacity with God with man and man with God. And then man had a better idea. And if that's the case, then we believe that man was the coupling between heaven and earth. In fact, I believe that man was the vessel through which God was manifested in the earth. Think about that? That in other words, you know, Jesus made a statement, if you've seen me, you have seen the Father. And I believe that means that the aspects and capacity of the Holy One was so manifested in Jesus that Jesus, God was coupled to the world through Jesus. That makes sense to everybody? If you don't see what I'm talking about, say something. We'll rephrase, or I'll speak louder. And if necessary, I'll wave my hands. So preachers, if you're a little unsure what you're talking about, you speak louder and you wave your hands. Pastor Dye is going to hate me for saying I've given away all the secrets. Okay. After the fall, then, you know the story. The cherubim was set at the eastern gate, guarding the way to the tree of life, which was communion with God. Which is union or communion with God. Man was prevented from approaching God. God wasn't prevented from approaching man, but man was prevented from approaching God. And hence, our capacity in that state, our capacity to interact in that heavenly realm was greatly limited, or perhaps we could say eliminated. I'm not sure just to what degree we'd have to say that. But I think all of us have felt how difficult it is to reestablish and grow and prosper in that realm. Okay, now, one view of redemption that I'd like to suggest is that God is reestablishing the coupling between heaven and earth. Everybody can understand what I'm saying? God is reestablishing the coupling between heaven and earth. Now, if you're looking at God's perspective, you'd ask yourself, is there a particular area on planet Earth that is uniquely advantageous for reestablishing this coupling that once existed, God would say, between me and Adam? Is there a particular, or is all areas exactly the same? Maybe it doesn't make any, he could go to Missouri. Maybe. But the Bible would tend to signify that there is a geographical area that is has a unique capacity for this coupling thing that's trying to take place. Don't get too far ahead now. You must have read the book. All right, so this area, particularly right in here where this is highlighted, the top of it would be, this is the Sea of Galilee, and this is the Dead Sea, or Sea of Salt. Jerusalem located here. This ridge area right in here particularly, the media calls it the so-called West Bank. I don't hear that too much anymore. It's Judea and Samaria. This area where about 95% of your Bible comes from, the encounters with God that are recorded in the Bible, a vast majority occurred right in this region. And there's many, many accounts of that. We'll get into that as we go along. So I want to suggest that there is a specific geographical area that is unique in all the world and relevant to this redemption process as God is reestablishing the connection, reestablishing the coupling to the earth. Okay, some pictures. That is some of the terrain that we see in Judea, Samaria. You probably recognize that place, I bet. More of the mountains of Samaria. More of the mountains of, I mean, this is not Iowa now, so God didn't choose it for a cornfield. A few years ago, we drove in this, actually in late July, through Illinois, Iowa, up in the Dakotas on out west, but particularly in those areas, I have never seen so many corn and bean fields in my life. As far as you could see in any direction, it was incredible. Productivity is just almost unlimited, it would seem. And you can get, well, it looks like you're growing rocks on this place. This was not chosen for agricultural purposes. It had to be some other. This was not chosen because it has some great strategic military significance. It has, I don't think, any. It wasn't chosen because of great natural resources. As Golda Meir once said, Moses found the only place in the whole Middle East that didn't have any oil. Not natural resources. Actually, there's only one aspect of this land that it really adds any significance. And that's it was chosen by God. That's the only significance. You can walk throughout the land and you'll see it. It's true. It was chosen of God. It has some significance in God's mind that we don't see or understand probably. All right. So we get to Jacob's dream. So God initiated this process of reestablishing this coupling. So you see, when man was cut off through his sin, earth was left submitted to a very harsh ruler. And that is mankind under satanic deception. And see, God really is the ultimate environmentalist, if you think about it. The ultimate environmentalist. And what you remember Paul writes in Romans 8 that the critters were subjected to what? Vanity? Subjected to it. Which means mankind under satanic deception. And listen, the truth is we are destroyers. We were created to bring God's glory and purpose and authority into the earth, and when that got cut off, we became destroyers, and we are destroyers. I'm a vegetarian except when we eat hamburgers. I wouldn't go out and kill a poor little animal just to eat something, would I? No, I wouldn't do that. But I'll go over to Walmart and you can buy pre-killed food. Somebody did on your behalf. Okay. We're destroyers. Let's admit it and just go deal with it and go on about our business. God's fixing stuff. He's a fixer and he's fixing stuff, and so that's part of it. So anyway, we had, did I skip over, did I clip it? Well, look at there. Oh yeah, let me see what we're doing here. Let me see if I can move this around and get that guy back. All right, Jacob went up that ridge that we were looking at a minute ago. He was running from his brother. His brother said, I'm going to kill you as soon as Dad dies. And so Jacob, he wanted to stay, but his feet just wouldn't hold. And so he headed for the land of the rivers, Mesopotamia. Actually, Syria, probably upper Syria, near the Euphrates. Anyway, he headed out and he stopped overnight. There wasn't any Motel 6 there, so he just stopped where he was, and he couldn't find what was that guy selling pillows on the TV all the time? What's his name? Mr. Pillow or something? My Pillow? He couldn't find My Pillow, and so he got a rock. It wasn't that hard to find a rock. You've been there. And so he slept overnight at, did I change it again? Yeah. I have to lay that thing down. All right. Hey, all right. So he had a dream. And the dream was that he saw a ladder with his foot on the ground. There's some debate about that. But the top was reaching into heaven. So this ladder was coupling in the context of what we're talking about. The ladder was coupling, and at the top of the ladder, who did he see? Well, he saw God. It doesn't say Jesus. Maybe it was Jesus. We don't know yet. Sometimes Jesus shows up there and you're not sure. Maybe. Anyway, he saw God, let's say. That's what he said. And he saw angels now. What are angels? Messengers. He saw angels up and down the ladder. See, the ladder is coupling. You see what the vision that he's given Jacob here. And Jacob said, hey, this is kind of a unique place. I believe this must be God's front porch. That's what I call it. He called it Beit El. Beit in Hebrew means house, El, God. This is none other than the house of God. And it's God's garden because it's his front door. It is Sha'ar Hashemayim. It is the gate to heaven. So it's like Jacob could see a vision of, you've seen these fences around people's front yard with a nice white gate on it. You just swing it open, you walk through, and that's where Jacob was. He was at God's front door. That's what he saw. And the ladder was coupling. Okay, let's go on. Now, John chapter 1, verse 51, Jesus said, he makes this statement. Oh, I love this statement. And he said to him, I say to you, you will see the heavens open and the angels of God ascending and descending on the ladder. On the Son of Man. The Son of Man is the ladder. Jesus is the ladder. Jesus is the coupling device between the heavens and the earth. Follow me? Everybody's happy? We brought cookies. If you're not happy, you better go get a cookie. By the way, as we continue in this class, donations of cookies as you bring them in are permissible. Now, Ms. Joe is with us tonight. She didn't used to come to all the classes, but I was out here every night. And so I used to tell everybody I cheated on my wife because I eat cookies here. We don't allow that stuff at the house. Taste. We didn't have banana pudding very often, only special occasions. Okay, now every one of you chose somewhere there happened some dimension of revelation come into your life that caused you to recognize Jesus and to acknowledge him and ask him to be Lord of your life. And you were joined to Messiah Jesus, so you have become a part of the ladder. As he is, so are we in the world. Everybody can see it. I am the ladder. Say that with me. I am the ladder. I am the ladder. I am the coupling between heaven and earth. I am not just me personally. I am a part of that mechanism that God has chosen to put into operation that couples the heavens and the earth. Your real interaction with beings in the heavenly realm now, we talked about what that was. The sum of, we did the sum of P, Q, R, and however many dimensions, all of there are some entities that live in this realm. There are some, we'll call them folks, that live in this realm. And principally is the Holy One of Israel, our Father, our Heavenly Father. Everybody knows who I'm talking about. The God of Abraham, the God of Isaac, the God of Jacob, that's his personal name. Messiah Jesus, are we sure Messiah Jesus is up there? Did the Bible says that that Peter and John and those guys were standing out there on the Mount of Olives, and this resurrected Jesus was walking around talking to them, and all of a sudden he was lifted up into the heavens, into a cloud. He ascended, and the angel said, don't be fearful. In the same way that he went up there, he's going to return. He's not through here. So Jesus is in heaven, isn't he? Everybody believes that? Jesus said, I'm going to send a comforter. When I go, I'm going to send a comforter to you. And who is that? The Holy Spirit, the Ruach HaKodesh. I'm going to send the Ruach HaKodesh. And so these are at least three inhabitants of heaven that you have interacted with. Is that true? Anybody here had never interacted with any of these guys? I call them guys. If you're real liberal today, I guess you maybe want to call them girls. I don't know. I'm not sure there's a sexual context to it, or a racial context, or any other context. In that sense, they are who they are. Creator, sustainer, redeemer, Lord, master, whatever. I believe that the PQR dominates the XYZ creation. Okay, I believe Jesus amply demonstrated that. Okay. So you have interacted with, you have a faith experience in you, and some of you have a very bold faith experience. Others might say, well, mine's not quite that bold. But you have a faith experience in which you have interacted in some degree, in some dimension, with the Holy One, the Messiah, and the Holy Spirit. It doesn't matter. Interacting is the two of you. It's the communion between the two. And you have experienced. Anybody here that never had their heart melt in worship? Okay, let's go to the next step. In true body, let me say this. In true body worship, you are stepping into PQR space. And if you're not stepping into PQR space in body worship, you are not in worship. You're in a religious service. Can I say that again? Now, I don't want to be mean about this, but it's just simply true. No, and people are very uncomfortable about walking around in PQR. I've seen people come into church and just sit in the back and just hold on to the seat. As a matter of fact, the first time I ever encountered it, that's what I did. And we sat next to the back door. So if this thing got too unruly, we could get ourselves out of here. I mean, you know, we were respectable Baptists. We can't just be doing stuff, you know. We don't know for sure what these people do. So, all right. But beside all of the stuff that's religious, a true body worship experience is walking in PQR. And if you're missing that, which I have been, you are being deprived of the most incredible thing that's possible on this planet. It's just true. Joe and I are testimony. And man, we've since our time in Kentucky, we visited a bunch of different churches, all kinds of different groups, and no body worship. Some very refined, some very loud, but no body worship. And so we finally just settled on going to nice folks, not far away, don't have a long drive in the morning. And that sounds, I know it sounds terrible, and I shouldn't have said it. but it's sad. It's incredibly sad. If you're not experiencing body worship as a believer, you're being now we talk a lot today about people that are discriminated against in one way or another. You are being incredibly discriminated against if you're not experiencing PQR body worship. Because you were called for that very purpose. No greater purpose that you have. God's building a ladder. No greater purpose. You can see the starving kids somewhere and get humanitarian aid to them, and that's a wonderful thing. You can see. You can be a part of the social, what do they call it? Social justice crowd, SJ. What is that? Whatever it is. That crowd, you can see social injustice. You can get excited about that. You can be a super Republican, maybe a super Democrat. If you're a super Democrat, you're having to continue to vote here in Florida for an extended period of time until...
Repeat it.
I wanted to register as a Democrat so I could vote more than once, but I said, no, I won't. So anyway, but the most awesome, serious discrimination that you could possibly experience as a believer would be to be going to a religious service and not walking in PQR. And I tell you, it is as rare as they say in the country as hen's teeth. Rare. Because it's hard. Believe me, I was a pastor here for 35 years. There was no greater struggle than maintaining a body of people in such unity that we could walk together hand in hand into PQR. All right, I'm going ahead. Christianity has the vision of escaping earth. I'm going to die and go. He's going to a better place. You've heard that, haven't you? Uncle John, he died and he's gone to a better place. Well, maybe he has. I don't know. But the vision is escaping here, getting over here. That's Christianity. The Tzemach vision is bringing this here. And see, it's hard to sell that one. What do I have to do, Jesus, in order to try to accomplish this? Well, you have to die to everything. You have to give up everything. You have to discipline yourself. You have to love one another. You have to give everything. Now, on the other hand, if I want to do this, I just check in from time to time. I would check in. I come, Sunday morning maybe, when it's convenient. If University of Kentucky's not playing round ball, I'll come. Of course, if the game is early Sunday afternoon, I'll leave early. Or if the University of Florida is playing football, I guess. Or, hey, these days, UCF, I guess, huh? UCF plays football these days. I went to UCF years ago. I don't think they were playing football then. I don't know. Anyway, I just took a couple of courses out there. They don't admit it, I don't think. Anyway, you're part of the ladder God's building you're bringing, and remember the Lord's Prayer, thy will be done on earth as it is already being done in heaven. Okay, everybody's got that? Okay, let's see what else we got. Tzemach vision. I would like for you to develop a mental picture of spending eternity on planet Earth, whether it's in the present age or in the new creation that is yet to come. You're going to be, you're supposed to be a part of the New Jerusalem, but the Bible says that the New Jerusalem is coming down to the new earth. So, folks, we're not escaping. See, if, when you die, you walk out of XYZ T's no more, you're going to make a loop. Bloop. Just like that. You're going to go Castleberry, Jerusalem. Bloop. No time. You stepped out of time. Bloop. Castleberry, Jerusalem. I've come to believe that the reality is that our experience is event-oriented, not time-oriented. Our thought pattern is totally time. I got one of these things on my wrist that tells me how much time, duration has passed. But the truth of the matter is, we're operating on an event orientation. So, I was conceived, I believe, on Thanksgiving Day, 1940. I think my mom and dad was giving thanks. I guess. That's the best I can make of it. Because I was actually introduced to this, outwardly introduced to the world. It's 9 months later, August 1941. So I was conceived. I could back up one more step. I was created in Adam, conceived, born. I have lived my life. It's appointed once for man to die. It's still future. And after that comes judgment. And after that comes, it doesn't really say, but what is it? When Jesus returns, I reckon I hope to be with him. Where's he coming to? He's coming here, Jerusalem. And I'm going to suggest that time is not even an issue here, because we stepped out of time. So it's going to be, I'm going to be, finally get to the head of the car, head of the what do you call it? The convoy of cars and someone's going to the cemetery. The what? Caravan. Well, caravan's not the word. What do you use for procession? Procession? Funeral procession. I finally got in the head car. And then next event is Jerusalem. Okay. You get the picture. All right. All right, this is a good place to take a quick little break. Let's take a couple of minutes and get a drink and whatever. Does these work?
I'm going to take this off you. I'll give you a new one here in a minute. I'll run out of batteries.
These don't work. I see. I always wondered about that. They don't work at all. You want me to turn it off?
Since I've been retired, Wendy had me to paint the whole house, but he got a 60 by 40 house. That thing's about 30 house. Now she got me painting now, 730 square foot worth of tile.
Yeah. See, years ago, I told him he is retired to real people. He goes to 18 wheelers for life and his wife. He is 18 wheelers to pay for the car. Anyway, he said, "Nice, I think we're going well, what happens is build up that whole storehouse and stuff that have to need to be done, and it's easy to put off. Now you don't have
So all the talk will start hanging out.
like so. Save the cookies, any leftover cookies goes to a poor preacher's home. They're all gone. All gone. That's what I was afraid of.
All right.
All right. About 40 years ago, I was engaged in physics classes and never imagined that, I guess the idea that they would have some biblical implication was far from my mind. That I would have any biblical implication was far from my mind too, as I recall. So, at any rate, this summer I was doing all my work, and I got in my book box and found my quantum mechanics notebook. Man, is it mean! Woo! So, but. Now, quantum mechanics is a relatively recent mathematical development science, and so it is not fully developed. I don't know how best to say it. It's not the whole story hadn't been told yet. Still in development. The theory has been developed and is being evolving as we go, and in years to come there'll be a more complete picture of the whole thing, I'm sure, because it is it's hard. It's not. It doesn't fit in the physics well at all because it's less than certain. And physics is supposed to be certain. Let me. I want to just go a very, very brief development here. If we go all the way back to the time of Jesus, the Greek philosophers considered the earth or matter made up of tiny little particles of some sort that they called atoms, and that was the smallest division of matter. Was atom. And they were pretty good for their time. During the period of following the Reformation, a period so-called Enlightenment and so on, in the like the 14th, 15th, 16th centuries, thought in Europe, developed in all areas rapidly, and particularly in science. We're talking in the eras of Galileo and Newton and scientists of that era, and many, many more. And so thought evolved, and as we approach the 20th century, late 1800s, excuse me, the capacity to deal with smaller and smaller entities were developed, and there were many, many advances that got scientists to dealing with down to the atomic level. For the first time, and so that is the whole beginning of the concept of quantum mechanics. New discoveries were made, all kinds of stuff in this. The speed of light was actually measured and determined to a high level of accuracy. Radioactive decay. A lady scientist by the name of Madame Curie. Anybody ever hear of Madame Curie? I think she probably got a Nobel Prize somewhere along the line. But she was working with radium, had some in her desk drawer. She happened to put some photographic plates in an adjacent drawer, and then after a period of time wow, all of our photographic plates were exposed. What did that? Radiation from the radium. And so she discovered radioactivity in that regard. So we're talking about, again, down to the atomic nuclear level. Maxwell in the 1860s, I guess it was, developed a theory of electromagnetic radiation. Light is actually a wave, electric and coupled with that magnetic wave. If you run electric current, you have a magnetic field around that current. If you have a pulsating electric current, like alternating AC, then you have a pulsating magnetic field around that. So if you put that together, you get EM, or electromagnetic radiation, which is light. Well, it's beyond just light. The whole spectrum, from infrared, low frequency, to gamma rays, are very, very high frequencies. So electromagnetic, photoelectric field. You could shine light on some elements, and you get the emission of electrons. Electrons actually being bounced out of the thing as a result of the light. Einstein described that process, and he received, I believe it's 1921, got the Nobel Prize for that. So we're making, I got some, I think, but I'll drink some more. Is this water though? Yeah. Yeah, I'm from Kentucky. This looks like lightning, maybe. White lightning. You had to drink a little of it to understand why they call it whiskey. Never made sense to me. Horrible stuff. You could drink kerosene. It'd be just as good. It's terrible. You used to have to doctor it up, put cherries in it, and all kinds of other stuff, just to make it so you could drink the stuff. I drink mixed drinks today too, a lot. I put Sprite in my apple juice. Okay, where do we get? Oh, you'll like this one. Big Al. Big Al developed, this is 1905, the theory of special relativity, and so he started playing. He's doing mental gymnastics with the idea of accelerating, continually accelerating objects, and develop, and it. You know, there's a mind like Einstein comes along every 400 or 500 years usually, so he's unique totally. But anyway, he envisioned this theory, and it's been proven. Proven is not the right word. It's been confirmed over and over and over again since that time. So today with massive accelerators that are available, you can actually accelerate items, entities up approaching at least in the ballpark of the speed of light, and it's confirmed. Now, one of the implications of this, and I want to do this and then play with that just a little bit. One of the implications of is that according to Mr. Einstein, the world, the X, Y, Z, and T now. Remember what we're talking about. We're talking about parallel universes. And so you say, why are we talking about this stuff? Well, there's a reason for it. X, Y, Z, and T, there is an absolute speed limit in X, Y, Z, T. And it's called C. It's always designated a little c. And it is 3 times 10 to the 8, or what is that, 300 million meters per second. 300 million meters. In miles per second, it's 186,000 miles per second. So it's right fast. Coach Diddle from Western Kentucky used to always emphasize how fast his basketball team was, and he wanted his basketball team to be so fast that when you shut off the lights in the gym, they would get into the showers before it got dark. And that's fast. So Ed Diddle. Okay. Trip over this. What did you give me, Willie? Let me back up. Oh, I'll leave that. That's okay. That's good. Can we see the board here? You can't see the board. I'll erase Schroeder. You don't need Schroeder. We won't get there tonight anyway. All right. Yeah, just for a minute, and then we'll turn back on. One of the concepts of that Mr. Einstein developed in this special theory is that if you took a mass of anything, what doesn't matter what, just a mass, and accelerated it close to the speed of light, the actual mass would increase. The effect of the mass would increase incredibly. I will show you his formula for that. So he said that if you, now we talk about mass as with the M, and I'm going to call M0 as we'll call it rest mass, mass that is at rest, not accelerated. So if you accelerate, you'll get a mass that is, the effective mass is equal to this divided by the square root of 1 minus the velocity squared over c squared. Now, does that scare anybody? This is language. This is just language. That's all it is. If I said it in Hebrew, it wouldn't scare you. It's just language. So if you increase the velocity as v here, it approaches c. As that approaches c, this ratio becomes effectively 1. And 1 minus 1 is, it ends up being 0, and anything divided by 0 becomes infinite. Anything divided by 0. How many times will 1 go into 1? How many times will 1/2 go into 1? 2. How many times will 1/3 go into 1? 3. And then we just keep going. All right. As you approach 0, the mass becomes effectively infinite. That's the implication of this speed limit, and that's been confirmed repeatedly experientially, and so you get this idea. The same thing happens to time and length and so on and so forth. We could play with those, but we don't need to. And I just wanted to put that up on there just to impress you anyway. doesn't have anything to do with the subject here. No, I'm just making the point that the incredible the early 20th century, the first 3 or 4 decades of the 20th century, there were just incredible scientific breakthroughs. I mean, in every direction. And Big Al did his part, obviously. Which side of these you... Well, you know, I was always suspicious of whiteboards. I love chalkboards. Hey. All right. Okay, so Einstein made his, and there were many. There was a model of the atom. This is the so-called Bohr model of the atom, and that is a nucleus. This is like helium, with 2 protons, 2 neutrons, with outer shell being full of 2 electrons. And the Bohr model of the atom is very much like the planetary model of the Earth orbiting about the sun. In the case of the Earth and the sun orbit, there is the gravitational attraction between the two, centrifugal force trying to pull the Earth off in one direction, the gravitational force balancing that, establishing a stable orbit around the sun. And so in the summer, we go up north. In the winter, we come down here because we're at a tilt, and I don't know if you noticed it, but the weather's nicer here in December than it is up there. You didn't notice that probably. Okay, so this model, it's a nice picture, but it doesn't work. Because the truth is that if you actually had, now the attraction here is the electrical attraction between the positive nucleus and the negative electrons. But if you actually had this, this guy would go spiral into the thing, and everything would change. And so it doesn't work. Now, if I look at this from the force acting on planet Earth from the sun is equal to a so-called gravitational conference. The mass of the sun times the mass of the Earth divided by the square of the distance between the two. So, and that in this case is 9.3 times 10 to the what? 6. 9.3 times 10 to the 6 squared, whatever. It doesn't matter. It's just a formula. So, but this would be the Newtonian pattern, or for the defining the force exerted on the Earth from the sun that keeps the Earth in a stable orbit about the sun. So you can work out a similar type thing for this pattern, but if you did, these guys would spiral into the middle, and the whole thing would collapse on you. So we know that doesn't happen. So Bohr's model is not good. Doesn't work. It works almost as good as that eraser. I would use my wet paper towel, but I don't want to do that. Okay. So as a result of that, the classical vision of the atom was insufficient to describe what was a real experience, so a new system of mechanics had to be developed to deal with the atomic structure in smaller atoms. And that is called quantum mechanics. People like Einstein, Heisenberg, de Broglie, Planck, Schrodinger, and so on are some of the leading physicists that dealt with these areas. Now, we're going to look at some kind. Now, let me tell you where we're going to here, so you can stay with me. In dealing with quantum mechanics, things get spooky, ill-defined, spongy, hard to nail down. Is it going to work? More or less? It'll be okay. We'll wash it after a while. In classical mechanics, things are very well defined, and that's one of the in my own life that was one of the real attractions that drew me into physics in the first place. Is that everything is, I mean, nailed down. We used to really, we hear about social. You've heard of the word used, social science. Well, on our side of the campus, we always chuckled at social science because everything they were dealing with was subjective, and we were the real scientists. We were the ones dealing with hard facts. Everything in physics is well defined. And so, if you take a normal force law, like this is typical Newtonian force equals a mass times acceleration. Okay? Now, so this is your Chevy pickup. This is your 327 engine. And this is your acceleration. So if I soup up, now I can't change the mass of my truck much, can I? Now today you'd put aluminum body parts on it and all kinds of plastic and all kinds of stuff. You could decrease the mass and keep the same force, and you accelerate better, wouldn't you? You could really rip those tires when you're taking off at the red light. Now also, if you really jack up your engine, increase the force, then you get better acceleration. So when I was a young man, I never had the money to do it, but I envied those guys that did. They would take an old Chevy and rework the engine and just put blowers on it and multiple 4-barrel carburetors and bigger pistons and all kinds of stuff. High lift cams and everything. What were they doing? They were increasing the force. The mass stayed the same, so they were increased. So they would. I drove an old '53 Plymouth. We did 0 to 60 in 5 minutes. So these dudes that. I knew a guy that ran moonshine, and he had a '55 Chevy with a big Chevy engine blown, and everything in it you can imagine. And man, did we envy this guy! But he'd rip his tires off every time, just smoke them. You've seen people do that. I didn't ever do that. I'd have to put gasoline on mine to smoke them, but that's what he did. And he made a lot of money, I guess. He was running moonshine. And you did this in order to go real fast and hopefully faster than the revenuers. That was the point. But from Newtonian or classical physics, if you control the circumstances here, you can calculate exactly what's going to happen, and it's totally reproducible every time, exactly, precisely. Classical physics and mechanics, totally dependable, absolute, ironclad. We love it. Quantum mechanics is not that at all. It's always a probability, iffy, out there somewhere. And that troubled Big Owl a great deal. Troubles me, not in the same way. I hate to think about being troubled the same way Big Owl is. So whatever. But it really is an issue. That would be one of the negative aspects of quantum mechanics, because everything's spongy, iffy. As a matter of fact, the best calculation can just give you a probability. And there's a reason for that, and that's the reason we're bringing it up. The reason for it is that, and this is my theory, you won't find this published in a book somewhere, but this is my theory. The reason for it is that quantum mechanics is only looking at part of the picture, not the whole picture. Quantum mechanics is talking about entities that is operating in both X, Y, Z, T, and PQR, or something. We can't declare that we're sure that it's PQR, which is heaven, right? So we could have a XYZ prime or something, an alternative thing. We don't know. We don't know. The one thing that we're confident of in the case of quantum mechanics, and there are all kinds of different theories, the most appealing to me is that there's an alternative space out there, alternative realm in which these quantum entities operate in, and that's the reason that quantum mechanics is always iffy, spongy, always dealing with probability, because we're not dealing with the whole picture. Everybody, I've wrestled trying to develop my own understanding to the point that I could hopefully convey some sense of what's happening here. It's a little bit difficult. For example, light, electromagnetic radiation. Well, we'll go to that, and then we'll come back. Electromagnetic radiation is manifested as a wave. I mean, it's electromagnetic radiation, a wave-type phenomena. So if we think it about, it's like an electrical current. You've got voltage swinging like so, okay? Voltage swinging. Light, different, bouncing back and forth like so, and being propagated in this direction, and building around this is a magnetic field. I don't know how well I can do this. A magnetic field that's going to back and forth like that, collapse, build up and collapse with it, and hence radiation. So we're talking about a wave phenomena. However, in order for light to have an impact on anything, it is received as a particle. Just one, like a, and that's where the idea of a quanta comes from. Like a package or packet of energy that maybe hits your arm or whatever. I'm sorry.
Can you show the example maybe about this of the electron shells and the...
Yeah, I'll get to it because you see that same phenomena. It's all right. So it's very, almost, I guess, all quantum entities. Now, when I say a quantum entity, I'm talking about something down on the atomic scale. We're talking about electrons, we're talking about protons, neutrons, quarks, neutrino, all kinds of exotic stuff that no one's ever seen, by the way. Hey, isn't that nice? Now, okay, I didn't talk about that. We're talking about dimensions. We're talking about dimensions that are less than minute. We're talking about, now, a meter is 39.37 inches, just about a yard, a meter. All the Europeans use meters, all of the science do. All right. We're talking about stuff here that, well, if we're talking about, well, let's just talk about green light. Everybody's seen a green light somewhere, haven't you? Green light, something like Willie's shirt, something that green. Green. Well, there is a specific nature of light, electromagnetic radiation of a right frequency that that our eyes respond to it with the phenomena of the impression of green, and the wavelength of that, or the frequency, I should say, not the wavelength. The frequency of that is about 1 × 10⁻15 cycles per second, or hertz. And those are approximate numbers. So what does that look like? That's 1 0 0 0 0 0 0 0 0 0 0 0 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 cycles per second. That's a bunch of them. I did a calc here somewhere. Where did I put it? I think I wrote it somewhere. Oh, yeah, here it is. The wavelength of that green light, I believe it's green. Yeah, it's green light. The wavelength is 6.56 × 10⁻⁷. So that's 6.57 10⁻⁷, 1 2 3 4 5 6 7 meters. Okay? So, if I did it right, yeah, I think that's right. 6.5 × 10⁻⁷, 0. This many zeros, 6 meters. Not a tenth of a meter, not a hundredth of a meter, more like a millionth of a meter. That's pretty small. Okay? So we're talking about, in all of these quantum entities, we're talking about incredibly small measurements. Now, it's incredible that mechanisms are developed. I did a hand-ground Newtonian telescope in optics class one time, a long time ago. Ground it out by hand. I know who. Anybody guess whose ringtone that could be? That's Rabbi Wallman calling, I think. The only thing is, it's 3 o'clock in the morning, and I always like to do that in a restaurant. You know, what? You check the Israelis. They'll. So okay. Well, I was talking about something. I don't know. We're talking about. I was talking about the a hand-ground reflecting mirror, Newtonian type telescope, a 6-inch mirror, and we had to get it to a quarter of a wavelength of light, a quarter of a wavelength accuracy. Now, a machinist would appreciate what I'm talking about, I guess. So, So it was a lot of fun. So we're talking about incredibly minute quantities in all of this. So you can begin to get a sense of the difficulty to deal with. Okay. So quantum entities in these extremely small quantities all seem to exhibit this wave particle characteristic. Now, the truth of the matter is, now the most advanced thought that I can find in quantum mechanics today is that they're throwing out the wave particle duality. It's all waves. And I want to suggest to you that they're operating in this alternative space, and it only becomes a particle when it's forced to be manifested in X, Y, Z, T, space-time. When you measure the stuff, and you're, in other words, you're taking a photon and bouncing it against some sort of screen, like a the old television screens use electrons bounced against what do you call it, phosphorus type surfaces, whatever that would glow if an electron struck it. And so you could develop by sweeping it, you could develop a picture with it. I'm old. I lose thoughts. And it goes, what time is it? Gosh. I feel like I need to have my pajamas on. What am I doing here? Okay. All right. So, well, if we couldn't have fun. All right. So anyway, these quantities are incredibly minute. All right. Now again, in classical physics, you can measure things with reproducibility, absolute certainty, whatever. In quantum mechanics, the best of calculations gives you only probabilities. It's always less than, and so it's very undesirable in that sense. And whatever. Okay. So let's go on. Now, some of the entities that we're talking about, I went over photons. It's just pure light, no mass, travels at the C. Again, you know, the amazing thing is takes 8.5 minutes for a photon or a wave leaving the sun, coming to Earth, radiating in all directions, but some of it hits here. Thank God for that. It takes 8.5 minutes for that to leaving the sun, arrive in the Earth. So if you go out in the morning and look at the sun, it may have disappeared 7 minutes ago and you wouldn't know it, because it would take that long for the info. Now, the nearest star, Alpha Centauri, how far is that? I think it's 4.5 light years away. Light years. How far will light travel in a year? Quite a ways. You want to calculate it? We can do it. 186,000 miles per second time. You can just start calculating, running it out. You get the numbers. It's not that difficult. And you got how far away Alpha Centauri is from us. And that's the nearest star system. And so if you now you look up at night, everything except if it's got red on one side and green on the other flashing, that's not a star. It is to me, but so far. but the heavens are sprinkled with stars that are incredible distances away. We have no idea. Many of them may have disappeared. We don't know. Maybe they could have more likely disappeared, meaning they would have fallen into a black hole. So, by the way, according to, now this is hard stuff to get to, but according to the folks that work on this sort of thing, about 95% of the XYZT is invisible to us. Only about 5%. In other words, you look out at the stars at night and somehow weigh all of those and calculate that, and you'd come up with some mass, and that's 5% of the totality of the physical creation. The rest of it presumably is black holes or something like that. So how would they come to that kind of thing? You ever think about the math that you would have to calculate there? It'd be a lot of fun, wouldn't it? Well, we had a formula for the Earth and the Sun, how that works. And if you start putting together the whole galaxies, you can do the same thing with them. But when they do that, they find that the force that's being exerted is much more than what's apparent. And so there must be much more gravitational pull than meets the eye, so to speak. And so hence the conclusion. So, all right. So, but that's not heaven. That's just dark holes, black holes. All right. We've spent enough time there. I'll go on. Okay. John wanted me to get to an atom. So this is kind of this is again getting back to the Bohr model of a. Anybody tells? Oh, it tells you at the top what it is. I was going to have you guess. That's carbon 12. Carbon 12 has has 6 protons, 6 neutrons, and of course in orbits about it is 6 electrons. So now there are numerous shells or quantum steps that these guys go out that they operate. In other words, you can have an electron there, but you can't have an electron there. You can have an electron there and there, but you can't have one in between. There is a very exact location, distance-wise, I might say, from here, from energy-wise, it would be more correct, between the orbits. And so these things have to operate. Now, and the reason for that is because these things are waves. Now we think of these little electrons as little pellets flying around in the corner, but that's an outdated model that all of us have stuck in our heads. These are not little pellets running around in a circle. They are waveforms. Now, let's just look at this one and this inner circle, and let me draw a picture up here, and I'll try to illustrate for you what we're talking about. Boy, that's hard to erase, isn't it? Whew. Doesn't do much, does it? I'm on last resort. Well, I knew I didn't like whiteboards. All right. So let's take our nucleus, and let's take our supposed orbit around there. Okay. Now I'm going to arbitrarily choose a point here to be the starting point and the ending point. Okay. And instead of that orbit, I'm going to just take that boy and stretch him out. Okay. And I'm going to draw him down here on a line, and this is going to be the starting point, and this is going to be the ending point. Everybody's following me? You can't see. That's going to be my starting point and ending point. It's a wave. It's what's known as a standing wave. And that's all that's permitted in that inner orbit. So that instead of a little pellet flying around in a circle, like a lead ball on a string that you're doing that to, which is what instead of that, it's a wave, a standing wave at that whose wave. Now you know if I take a banjo string and I pluck the banjo string, what happens, Mr. Wingirter?
Well, we say it vibrates, but it moves
okay.
one side and across to the other.
Okay. So it vibrates back and forth, and if I change the length or mass of the string or the tension, What changes?
The speed of the vibration.
Yeah. How about the frequency of that string? Now, if I leave all of those things constant, then that string is going to have a given frequency in it. So you got a little tuning job out there that tells you when you have it at what, D, F, G, whatever note, D, what's country music? F, G, and what? C? Whatever it is, you know what it is. There's everything's country music, just different countries. So you have to get used to that.
And when you tune in A on the piano, it's still the key.
Okay.
440 cycles a second.
Okay, so you got 80 what? You got 88 keys on the thing. So the middle what?
Well, pretty much right in the middle of the keyboard.
All right, so 440 cycles per second. So that's pretty slow relative to what we're talking about, but whatever. It's a tone that you could hear and understand. Humans only respond to a very limited sound spectrum. We hear it best from about 50 cycles. If you're real young, you might get down to 20. I don't know. Up to about 20. If you're older, you get up to about 20,000. You get up about 10,000. As you get older and older, about 8,000. Pretty soon, huh? What? So, but anyway, a musical string has a given frequency, and it is a standing wave like that, and you get harmonics, multiples of that. You get harmonics of it on it too, and actually, the same thing happens. The same thing. So the electron is really a wave phenomena. Around it. So it can only, now, when you go to different levels, different orbital patterns, there's different electrons out here, then this electron over here in this lower one, you can have a photon of energy coming in and being deposited on that, and if it is, there is a change of energy between these two levels, and if you get a photon that matches that same energy level, then it can be absorbed by this, and you pop this guy up to there. Or if it's up to there, he can pop down to this level, and he'll send out a photon of that green color or whatever. So, where does white light from the sun come from? What's happening on the sun? Yeah, it's basically a big hydrogen-helium oven, fusion oven, and this is emitting a whole array. Now, you don't just have visible light coming from the sun, do you? On a cloudy day, you go to New Smyrna, sit out on the beach, and you still get sunburn. So, and we were talking about when I was in the Navy a long time ago, worked in electronics, in radar and so on. And if you worked in radar, you worked with waveguides and high-frequency radiation. And if you tended to wear rings and stuff like that, playing with that, you hurt your finger. Burn it off if you're not careful. You have to be careful. Don't wear those rings around here, boy. Knothead. You know, don't, because it would absorb the radiation sufficiently to really get you in trouble. So you had to be careful. So energy can come into these things and lift them to higher orbits. It has to be the differential between the two. And if it goes from here to here, it will give off a specific, as a matter of fact, a spectrometer you can take an unknown material, put it in a spectrometer, and what you do is excite the electrons here to the point that they're falling back into their lower orbits, and each atom has a spectral pattern that shows up, and you can identify a substance that way. Whether it's carbon or oxygen or hydrogen or whatever the substance is, everything has a characteristic spectral lines. The scientists that are looking at stars way away are looking at that spectrum, determining what kind of light. We see white, which is a combination of a bunch of colors, but if you put that in a spectrometer, you can break down and know what colors are, and therefore you know what kind of atoms we're dealing with. So you watch these guys on Nature, on PBS or whatever, and all this fascinating stuff that they come up. That's how they're doing it. Okay. This is just another. This is the hydrogen atom. These are different quantum numbers going out from it. Not quantum numbers. There's another name for it, and I can't think of it. It doesn't matter. The so-called Lyman series is a series of spectral lines in hydrogen coming down to that lower orbit. I think I've got another slide on that. Oh yeah, there he is. Can everybody see that? A little bit small. All right, let me show you. These numbers that you see are wavelengths, and if you notice they're in nm, which is nanometers, 10 to the minus 9 meters, 0.0000000 meters. So, whatever, nanometers. Now, the Lyman series at the top, Balmer series in the middle, and the Paschkin series at the bottom. These are the wavelength of the photons here are 1,094 nanometers. That's in infrared. That's infrared. Where do you get infrared heat? What do you have in your house that generates infrared heat? Microwave probably, doesn't it? It heats up water pretty good, doesn't it? All right. You don't see it though, do you? But you can't stick your hand there and close the door. It's fortunate that they make them so you can't stick it. Because you know what somebody would do. Let's see, how does this work? So, the Balmer series is in the visible range. You can see, it's like a rainbow. Violet, blue, orange, yellow, yellow and then orange and red. Well, green was in there somewhere, I forget. All right, so, but these wavelengths would represent visible stuff, and the stuff up there is ultraviolet. That's gamma rays or whatever. That's what you get burned up at the beach on when you're not paying attention. Gamma rays, higher, you can't see those either. X-rays, gamma rays, and so on. Those would be the shorter wavelengths, higher frequencies. We said the frequency here, the visible green, was about 1 to 10 to the 15th cycles per second. These would be much higher frequencies. I calculated the other day what the highest frequency you go to. I forgot what it was. Okay. Now, all of these entities, electrons, protons, neutrons, quarks, whatever. Quarks, by the way, quarks, individual quarks do not exist in space-time. They only occur in space-time in units of 3. And they're the components of protons and neutrons. they're not found in space-time themselves. Well, if they're not in space-time, where in the world are they? Well, they're somewhere else. And what's the somewhere else? Now, why am I going to all this difficulty and snowing you this way? You know what a snow job is, don't you? I always appreciate a good snow. You ought to pull your pant legs up just a bit. So why are we talking about this? I want to convince you. Now, we don't know. Now, where do quarks exist at? We don't know. They're not found individually in space-time. My conclusion is they exist somewhere, so it must be an alternative thing. Could it be PQR is where they exist? I don't know. They could be. But whether they do or do not, here's why I'm getting into this thing in the first place. I want you to be convinced that there is an alternative universe setting out here. Now, science is dabbling with that. One of the statements I had on one of the slides is, what have we stumbled into? What has science stumbled into? And they have stumbled in, that's what quantum mechanics is all about. They are dealing with something that's unseen, unmeasurable, and therefore not predictable. It's out there somewhere. There is an alternative universe operational out there somewhere. Maybe it's heaven. We don't know. Maybe it's just an alternative physical universe. That's altogether a possibility. But from what I want you to be convinced of is there is such a thing. And so the idea of heaven being an alternative realm of different dimensions is not some sort of spooky daydream fantasy or something. It's very much a reality. And we know the guys that live there. And you have been called to become their companions and their workers. You have been called to walk in the likeness of Jesus the latter. See, that's why if you're not experiencing PQR in your worship experience, you're being deprived of the most essential aspect of your salvation. Now, why did Jesus call me? I can't figure it out. I don't know. Miss Jo married me, and she was absolutely sure that the very, very last possibility she shows you what did she do? What did she do that got her stuck this way, huh? What did she do? She must have done something. You know, Job's friends, they said, Job, what did you do? You can say, Miss Job, what did you do? You married both. But I always say that I was a very poor atheist. I was an atheist, but I wasn't a very good one. Because if I'd been a real good one, I'd probably still be one. But I wasn't. And so somewhere down the line, Jesus stepped out of PQR and right into my XYZT and says, hey, you. Remember he did that to Paul. Paul was on his donkey going to Damascus. We're going to get those guys. Get along. and all of a sudden, phew. Why are you persecuting me, Saul? Shaul. Is that it, Shaul? Why? Who are you, Lord? Who are you, Lord? He knew the Lord part by that point, didn't he? Who are you, Lord? I'm Jesus. See, Jesus stepped right out of PQR right into Paul's XYZT. And man, did we make it. And he did the same, not exactly as profound as that, but Jesus stepped into my XYZT also. And everything changed. Everything changed. Everything changed. And it's a wonderful thing. That's a wonderful thing. So I want you to grasp that you're not just tolerating this. There's some pretty ornery folks around us, but the truth is we're kind of ornery ourselves, aren't we? But that people cut you off, run around 436, and this Baldwin guy, he's an actor or something, I guess. I don't know. I've never seen him in anything. But somebody got his parking space up in New York City, and he punched him out for it, I think, something like that. Got locked up last weekend, I think. People do stuff like that. Look at the guy in California, an ex-Marine, walks into a nightclub and shoots down, 12 people? And then I guess somebody killed him. Or he may have shot himself. Now I was stuck in California once too, but I left. Gee, I could have gone into a club too, but I didn't. I left. So, always careful what I say about California because I'm afraid the Lord would say, Ken. So I'm real careful. So there's nastiness all around us. And are we going to see nasty in the next week or two in Florida? We're going to see nasty. I mean, it's going to be nasty. As we speak, there's plane loads of lawyers flying in from everywhere. Did you know that? Plane loads of them flying in, and the games begin. And so it's going to be nasty, nasty, nasty. You thought it was all over Tuesday, but we're going to play nasty for long. All right, so life can get kind of tough. And, when you get my age, things are not looking optimistic, physically speaking. I mean, when you're, my brother used to say, when you're 20, you feel like you're 9 feet tall and bulletproof. But at this age, you're not so sure. So life is tough. We all recognize that, some aspects of it. But listen. You have been set aside for a purpose that is out of this world, should I say? It is. We're engaged in the process of being assistants to God, bringing PQR down to earth, fulfilling Jesus' prayer, "Thy will be done on earth as it is in heaven." We're engaged in that process. So get into this PQR thing. There is a reality out there. You're not going to die one of these days and go off and float around on a cloud with a harp, a halo, and a harp, and how long would that last anyway? You'd break your harp. Who knows? Fall off your cloud, break your harp, lose your halo. I mean, it wouldn't last anyway. Who wants to float around on a cloud indefinitely playing a harp? Okay. You wouldn't want to hear me either, I expect. Miss Joe now, she might. Jim might. I don't know. Yeah. All right. So anyway, you get the picture. Now I want to convince you. All of this stuff is to convince you that science, the best minds in science have stumbled, in my estimation, have stumbled into this thing, and it goes beyond space-time. Oh, I didn't tell you. There's other things. Let me get this slide, and we're going to come back next week and try it again, because I know I didn't communicate effectively. Let me show you this slide. All right, can you see this? It's called quantum entanglement. Quantum entanglement. Now this is the one that blew everybody's mind when they discovered it. So you have a single source of photons flying out in different directions. You can envision that they're going out miles and miles apart, good distance apart. And you do something to this photon. Actually, they're filtering it, polarizing it is what they're showing here. Polarized. You have polarized glasses. They're filtering out some of the rays that are coming in. That's what polarized glasses do, aren't they? So they're polarizing this photon. Notice he's going in every direction here, but he's going a singular direction on the other side. They're polarized. It doesn't matter what they're doing to it. But what you need to know is that now these are miles and miles apart. Doesn't matter how far. But when you do something into this guy, you do the same thing to this guy miles and miles away, instantaneously. And the velocity V is much greater than C. Do you see that? Now, what did we say Mr. Einstein said? The speed limit? C is the speed limit, isn't it? C is the speed limit. This thing happens like instantaneously over a great distance.
They're both coming from a single atom.
Yeah, they're unique. They're called entangled, but they're traveling out in different directions, and they're separated by, we'll say miles and miles. I don't know what the distance is. They're separated, and you hit one and both feel it. In other words, there's a communication between them instantaneously, outside of time. There is a communication between them outside of time. Who walks outside of time? God does. Jesus does. Everybody see this? Now this is not my speculation. Now some of the stuff I shared tonight is my speculation. This is not my speculation. This is scientifically demonstrated, repeatable. And so the velocity which this communication occurs is much greater than 3 times 10 to the 8th meters per second, the speed of light. Meaning that it's something happening outside of space-time, in the alternative realm. Just another one of those things that tells us that there exist alternative realms. And the Bible declares that heaven is such a thing. Heaven is my throne, earth is my footstool. So heaven is a real place. It's a real phenomena. It's got real dimensions. It's got real entities, personalities that inhabit it. And you have been joined to one of them. And you have been called into the service of the Most High God to function in this earth from that perspective. That's what I want you to grasp. And the action is here. Not floating around on a cloud with a harp. The action is here. And we're not going to wait till the millennium to get started at it. As a matter of fact, there's a promise. As often as I have gathered even 2 or 3 of you in my... I am in the... Oh, think of that. That's PQR, isn't it? Isn't that what that is? As often as I have gathered even 2 or 3 of you. So if there's 100 of you get together, you know, in the book of Acts, the rafters, they didn't have hurricane clips back then. So the rafters shook. I always been waiting for the... Now, I've nailed on half the hurricane clips on these buildings. I know where they are, but I'm waiting for them to shake. You reckon you might get excited with that? All right. Comments or questions? Does everybody understand why I'm beating you to death with this stuff? It's important that we crush this idea of Gnosticism, of floating off on a cloud somewhere. That is a terrible, terrible. What's the word I want to use for it? Cultic concept. It's a lie. It's a lie. It needs to be crushed. Needs to be crushed. Now, if I died going home tonight, I hope I don't wreck my car, but if I run into a tree and kill myself, to be absent from XYZT is to be present with the Lord. Remember events. Tree, Jesus, Jerusalem. Event. Tree, Jesus, Jerusalem. Forget time, because I stepped out of that. You see that? So we might as well get started now. You see, there's no reason to wait. Might as well get started now. Let's get ourselves in. What's the most important thing I can possibly do? Make sure I can step into PQR space. How do I do that? Well, you can do it kind of individually in individual prayer and worship, but it really becomes effective when several of you are getting together and the Master is in the midst of you. There's no promise that when I sit on my porch and I have Terry McCallan, is that his name? Singing songs on my computer, whatever he is. Terry, we just call him Terry. Whatever his name is, he's pretty good. But I can play him, I stand in awe. That's pretty good, huh? I stand in awe of... That's pretty good, I like that. All right, I can sit on my porch and there's no promise that Jesus comes and stands beside me. But when we assemble as a body, and I know that Jesus wants me here, and I know he's called Mr. Dorsey because he would have left if he could have, and Ms. Pat, she, and Mr. All these folks, see, have this calling to be that Jesus somehow led me around and put me right here. You see, together. And now, what's the promise? As often as you are assembled under my authority, there I am. In other words, we just stepped into PQR space. That's pretty important. You can't do anything in Jesus more important than that. As a matter of fact, if you don't do that, you ain't doing anything. If you're not doing that, you're doing absolutely nothing but religious exercise. And Jesus will say, "Phew, I never knew you." No, Hebrew, yada, interact. you see. Sort of important. Sort of important. All right, so we'll get to this next. Let me show you a couple more slides real quick. Those are pretty nice, aren't they? The message, all right. There's Mr. Schrodinger. You like him? That is a second order partial differential equation. There's nothing about that should scare you. Nothing about that. Well, psi is the wave function, a function. And so this is the first differential change of psi according to time, multiplied by Planck's constant, divided by 2 pi, times I, imaginary, is equal to, this is a sign for potential energy multiplied by psi, and this is the Hamiltonian, this is Planck again, Hamiltonian operator, which is the, where can I write it? I got no space. The second differential with x plus the second differential of psi with respect to y. Let me do that. Plus the second differential of psi to z. This is going to be on test. But so just that's what delta means. That's what this symbol, delta.
All that for change.
Pardon?
All that for just change.
Yeah. so actually, you could use. Now you guys are familiar with electricity. You could use that function on electrical circuit actually, because it's a waveform. It's a wave. It's called Schrodinger's wave equation, and it's a way of analyzing alternating wave type thing. It's kind of, but psi just represents the probability of something happening. That's why they say in quantum mechanics it's always a little spooky. So, all right, that's enough for one night, surely. Do I have another picture? Oh, I do have. How do you like that picture? That's nice, huh? This is a picture of a proton, and these are quarks. This is an up quark, and a down quark, and these are held together by what little g's. You wouldn't guess what they're called. They're called gluons. obviously very creative in naming stuff, huh? Gluons. All right.